Welcome back. Got another problem I want us to look at, but there was one thing I wasn't very clear about in the first video. These are two examples, again, of when we are concave down. Now, this one is increasing, and it's concave down, because as it's increasing, the quantities get smaller and smaller and smaller. In other words, they're getting, in this case, closer and closer to zero. It's increasing still, but it's increasing at a slower rate. So this has a negative second derivative, which makes it concave down. Likewise, this one's decreasing. Now, it looks like the rate that it's decreasing, it's getting steeper and steeper, but the quantity is smaller and smaller. These are negative slopes here, but the negative slopes have greater absolute values, so they are smaller numbers, so the second derivative is negative here. Now, let's get away from that for just a second and get back to the problem. My problem is this, so if you would, on your own, pause the video and do the second derivative. Okay, now that you've paused your video and you are back, let's look at this. F prime of x here, and I'm just going to do this one together because there aren't really any things here that should trick me up, although I have been known to make mistakes before. All right, now I'm going to go from here and I'm going to go down and do my second derivative here. Second derivative being 12x squared minus 24x. Okay, the reason I did that is I want to take the second derivative from this term, but let's factor this out and see what happens here. So we've got 4x squared can factor out, so we'd be left with x minus 3 here. So this means that this function here would change from increasing to decreasing or decreasing to increasing either at 0 or 3. We don't know. Again, it may not change either one there, but it could potentially change at 0 and 3. In fact, we'll see that one of them would not change. But going on to this problem here, this is, again, we're looking at the second derivative. Again, let me make sure I did this correctly. 4x cubed, okay, minus 12x squared. So this is 12x squared minus 24x. Okay, so let's factor out a 12x, and we're left with x minus 2. So my potential points of inflection are at x equals 0 and x equals 2. So these are where I could potentially change concavity. Now, let's look at this as far as the number line is concerned. 0 and 2. So let's try negative 1. All right, and I'm going to plug into this step here because this is where I have things factored down. In the last problem, which was a rational expression, we broke it down into the factors to determine positives and negatives. It made it a little easier. Here, all right, we got a negative, so 12 times negative, let's just say negative 1. 12 times negative 1 is negative. And then negative 1 minus 2 would be also negative, so a negative times a negative is positive, so we would be concave up. All right, at 1, you've got a positive here. 12 times 1 would be positive. 1 minus 2 is negative, so a positive times a negative would yield a negative, so we would be concave down. And then finally, we've got a number like 3, positive times positive, which is positive, so we're concave up again. Now, for the points of inflection, both of these will be points of inflection. Now, again, a critical number is just where the slope is 0 or undefined. You don't have to have a change for a critical number, but you have to have a change for a point of inflection. But we do change here, so we're good. Now, this would be 0. If I plug in 0 to the original function, f of 0 is 0. So we've got the point 0, 0. That's one of my points of inflection. And then let's plug in 2, f of 2. All right. 2 to the 4th is 16. And then it's minus 4 times 2 cubed. 2 cubes 8, so minus 32. So we get the point 2, negative 16. So that's my other point of inflection here. Now let's go all the way and look at what this would be as a graph. Again, let's take these values here for our critical numbers. 0 would be one of the critical numbers. 3 would be the other one. So we have 4 times 0, or f of 0, sorry, which is 0. We solved that earlier. Now, f of 3, 3 to the 4th, is 81 minus, okay, 3 cubes 27. 27 times 4 is 108. So we have 81 minus 108. $27. So we would have the point 3, negative 27. So looking at the graph of that, I'll show you what it looks like. It's in your text. But in fact, yeah, just look at your textbook. It's on page 193 of your textbook in that example 3. So that's a good example of what it looks like. You can see what happens when you have a critical number changing from increasing to decreasing. Actually, we're going to see if you plug in 0 here, this does not change. It's decreasing to the left of 0, and it's also decreasing to the right of 0. But it actually does change at 3. You're decreasing to the left of 3, but then you start increasing to the right of 3.